general result, it tells me that if we set the d equal to 3, it achieves the bound of 4. But as I mentioned earlier, we don't want to tell this trivial result because the value of 4 actually is a maximal algebraic upper bounds of this temporal characterization inequality. I hope I answer your question.
Okay, we can discuss later.
Okay, I have a quick question. So as far as I understand you, so you provide some achievability results to achieve certain values, but do you have any converse results for these temporal correlations? For example, like in the usual scenario, we know that like 2 times square root 2 is the best we can get for quantum entanglement. So in your scenario, do you have any optimality results?
So you mean if we check other different numbers of inputs and outputs, or? I mean,
by using any quantum strategies, you can like exceed certain numbers.
Okay, so here because we only consider a temporal scenario, so actually it has nothing to do with entanglements. So of course you can compare the bounds with the spatial case, like you test the standard CHSH inequalities and compare the bounds.
Yes, but I mean, if can you show that this 4 is the best you can get? Under various conditions. I call that the converse results. Like for example, Tyson's bound tells us that 2 times square root 2 is the best.
You mean a spatial case or a temporal case?
Spatial case.
Yes, for spatial case, yes, 2 square root of 2 is the best quantum strategy one can achieve. And for temporal case, it is not always the case because So first, because very briefly speaking, if you don't restrict this if you don't restrict the non-signaling times, this condition, then Alice has a possibility to send information to Bob. And this scenario is forbidden in a spatial scenario because in a Bell type experiments, Alice and Bob they cannot communicate with each other. So the bound is 2 square root of 2, but here the constraint is more relaxed. So that's why if you don't restrict these conditions, then you only restrict the first constraints, then you obtain a larger bound. So this is one of the examples why there's a difference between temporal and spatial scenario.
Okay. So let's thank Shin Liang for this wonderful talk.